Hi friends, Dr. Jim Daly here from Astronomy for Change. We're going to be talking about Mars a little bit, okay, and the idea of going to Mars. We're rapidly approaching the point in our growth and evolution here on planet Earth in terms of requirements for continued sustaining our population and our way of life. We're rapidly approaching the point where we're going to have to start thinking seriously about finding additional living space. Some people have suggested the moon, some people are suggesting Mars. Okay, the moon is a great resource for raw materials as a stepping stone, so to speak, to go to Mars. Our chances of long-term survival increase dramatically if we actually can establish a sustainable colony in either place on the moon or Mars. Mars is the better choice. The moon has no atmosphere. The moon is much smaller in gravity, has a much lower gravity. There are certain physiological effects from a low gravity environment that eventually take its toll, even if you have things like artificial gravity, which is hard to work out in situ in a place like the moon. So a long-term colony, sustainable colony, really is not practicable in the sense, in terms of amount of time, considering, even 5 years or 10 years for someone to live on the moon. There's certain serious physiological effects to one's body. The low gravity environment, for one. We evolved in an environment where we have 1G, 1 Earth gravity, right? So our bodies evolved in that. Our physiology, our muscle structure, our skeletal structure, everything is designed for a 1G environment. We go live in a 1/6 G environment like the moon. We have to make certain accommodations, and those accommodations right now, in terms of artificially creating a 1G environment, are technically not feasible at this point. So a long-term colony on the moon is really, it's a technical challenge, perhaps some kind of magnetic boots we could wear, things like that. It's not practical. Mars is a better choice for a number of reasons, right? Okay, in terms of its mass, it's much more massive than the moon. It's got about half the gravity or a third of the gravity as the Earth. In terms of the effects, physiological effects from a low G environment, low gravity environment, it's much less on Mars, albeit Mars's atmosphere is not conducive to our life as we know it. There's virtually no oxygen in the atmosphere, or very, very trace amounts of oxygen. It's mostly CO2. All right, so suggestions are being made by a number of high-profile individuals of late of terraforming Mars, since most of the atmosphere, even though it's a very light, very thin atmosphere, most of it is CO2. Okay, so what do we know about CO2 here on Earth? We know a lot about it now, right? How the plant cycle works. Plants take in CO2, the added energy from the sun through photosynthesis. The plant, produces oxygen as a waste gas and produces carbohydrates and energy and so forth. That's how plants work. That's the process of photosynthesis. So the thinking is to what they call terraform Mars, or produce an environment similar to that which is found on Earth. That term is called terraforming. There are certain ethical questions about this. It's a pristine environment, untouched by human hands. Do we have the right to go terraforming it? Who knows? Maybe in a generation, 1,000 years from now, they might look back on that and think it was not the right thing to do. Those are questions we can debate, but right now, our population on the surface of the Earth, we're getting to the point where we're going to need to seriously think about finding alternative locations to live, where whole generations, whole families can be born, live, and die on another world. Right now, all we know is being born, living out our life, and dying on this planet. But there will come a time, perhaps in the next 50 years, where we're going to have to find another place to live. Okay, the Earth can no longer sustain population growth at its current rate here on Earth. The numbers that I've seen put it at the year 2035. Beyond the year 2035, the Earth will no longer be able to sustain the population growth at what point it will be at that time. Okay, so Elon Musk has highlighted this issue again. Okay, his idea for terraforming Mars, and this was in the press, all right, and there was a lot of hype attached to this, that Elon Musk wants to nuke Mars. Here's an example, the sun. Monster smash. Elon Musk sparks asteroid apocalypse panic after warning Earth has no defense from deadly space rocks. That's one thing. Okay, we talked about that in the previous video. It's not going to happen. Okay, Apophis is not going to hit the Earth now in 2029 or ever. Okay, there is no alarm from Apophis. Okay, here's another one. Elon Musk wants to nuke Mars. NASA says it's not possible, and they're correct. In the scenario he describes, it's not possible. Okay, so let's go back and take a look at what he suggests. And it's not to drop nuclear bombs on the surface of Mars. That would be insane. It would render the entire surface of the planet uninhabitable for thousands of years from the radioactive fallout from even a low-yield nuclear weapon. Okay, so ethically it's out of the question. Okay, but that's not what he suggested. Okay, let's take a look at what he said. Okay, the sun is an immense thermonuclear explosion. Well, not the sun in itself. Inside the sun at its core is a gigantic nuclear fusion reactor. A reactor that's providing, at 15 million degrees Kelvin, an energy source that's providing the sun's light and heat, and is the principal source of our life here on this Earth, our energy requirements as a sentient species for our biosphere on the Earth. The sun is the principal source of heat and energy for us. Okay, so he goes on to say that the sun generates a lot of energy. Okay, it converts about 5 million tons of mass to energy every second. Well, that's not quite true. It's a lot more. Here, this is our reply to Elon. The sun converts 700 million tons of hydrogen into 695 million tons of helium every second. Through fusion, okay, a nuclear weapon, a bomb, or even a peaceful use of nuclear energy, such as a nuclear reactor, is nuclear fission, where we're splitting the atom, releasing the binding energy that held the atom's nucleus together. That's what happens inside when a nuclear bomb goes or explodes, or inside a nuclear reactor. A nuclear reactor is a controlled chain reaction where we're splitting uranium or heavy element atoms into daughter products or smaller nuclei, and thus releasing the energy that bound them together. Nuclear fusion is the opposite of that, where you bind them together and thus create a new element. That's what's happening in the sun, and that's what Elon Musk is proposing. That kind of nuclear reaction poses no threat to the environment, produces no dangerous radioactive waste products, or any kind of harmful effects at all. Nuclear fusion can and should be the energy of the future, and we have to work towards that. That's a topic for a separate discussion. Right now, the sun is converting 700 million tons of hydrogen into 695 million tons of helium every second through nuclear fusion. The missing mass of 5 million tons is the part of that was converted into energy, which then escapes from the sun, yielding about almost 4 times 10 to the 26 watts of power, or joules every second. Think of that, that's a 3.85 with 24 zeros after it, okay, in terms of watts. Think of that 100-watt light bulb you just screwed into your lamp last night when the light blew. Okay, you'd need 10 to the 24th of those to provide the same amount, to get a sense of this output, the energy output of the sun through nuclear fusion. Back in 1905, Einstein published his special theory of relativity. From that, just as an afterthought or as a corollary to his special theory, the famous equation that everybody knows, that Hollywood uses sometimes in error. A lot of people quote it in error, really don't know what they're saying. E equals mc squared. What does that mean? That's what we call rest mass energy. And that equation is used right here in the amount of energy that 5 million tons of missing mass is what was converted into energy, is what we feel here on the surface of the earth, what provides all the energy and is the principal source of energy for us to sustain our life here on the planet Earth. All life on Earth, right? Okay, so how does this work? Let's take a look at some of the basic principles involved. Okay. You look at the beginnings of the universe. The universe started with hydrogen. Okay, then helium. That's it. Where did the rest of it come? Where did the oxygen come from? Where did the nitrogen come from? Where did the carbon, the iron, the helium, all those basic elements, where did they come from? They came from the insides of stars. Okay, stars like our sun. In the case of heavier metals, heavier elements like iron, sulfur, silicon, that makes up our beautiful beaches here on the Earth. Those elements were then synthesized or forged in the nuclear cauldrons of high-mass stars. Okay, that exploded, ended their life in a spectacular fashion as a Type II supernova. From that debris, the death of a star, comes new life. Okay, because those are the raw materials that we need that make up our bodies, the hemoglobin, the iron in our blood. That iron was forged in a high-mass star and was released into the universe by a Type II supernova, where the star no longer able to sustain nuclear reactions in its core. The whole mass of the core implodes in on itself, rebounds in this unbelievable explosion we call a supernova, Type II supernova. Okay. If you think about it, okay, the materials that we use to produce nuclear energy here on the Earth today, in nuclear reactions, in nuclear reactors to provide to have a peaceful use of nuclear energy in the production of energy, light and heat for our homes and our civilization, that's fine. But it's a monstrosity when you think of what a nuclear weapon is. A nuclear weapon is the deliberate release of the energy of a supernova on an unsuspecting population or on an innocent population. The energy that binds those heavy nuclei together, the uranium, the plutonium, the thorium, those heavy elements were produced via in the core of a star, a high-mass star that exploded. The star is about 10 times the mass of the sun. And in the maelstrom following the explosion of that star, the energy released basically packed all these neutrons and protons together in an unfathomable release of energy that produced these heavy elements such as uranium, thorium, plutonium, all these elements that go into producing the fuel for a nuclear weapon or a nuclear reactor. So when you think about nuclear energy, for peaceful use of nuclear energy, think that energy, that electricity that you're using, was produced inside a supernova in the immediate aftermath of a supernova. Okay, so it's something to consider. Okay, so Elon Musk wants to ring Mars. Here's Mars. I think it is. He wants to ring Mars with a string of small fusion bombs, not fission bombs, around Mars to terraform or release the energy of the sun in a very dramatic, very short duration event that would terraform the planet, create an environment conducive to sustaining life our life as we know it on planet Earth. Okay, there's a problem with terraforming Mars, though. Mars does not have an ozone layer. What does the ozone layer on Earth do? The ozone layer on Earth shields us from the harmful effects of the solar ultraviolet. It was thought long ago that Mars was very similar to the Earth in some aspects, had vast seas, large bodies of water that over time, over the eons since Mars formed, that water has evaporated away, lost to space. Now, Mars does not have the same atmosphere as the Earth. Okay, it's mostly made of CO2, as we said. So the idea of terraforming Mars is what Elon Musk is suggesting. This is the proposal. Elon Musk's suggestion. He wants to bring Mars with a series, or more like a necklace, a pearl necklace of small yield nuclear fusion bombs. Although they wouldn't produce any harmful radiation, it would be a way to rapidly irradiate the planet with a lot of energy all at once in a very short time span. That's the thinking. Okay, there's a problem with terraforming Mars, and this conversation has been discussed now for decades, to terraform Mars. Previously it was thought that we could do it, that it would be a suitable environment, that we could actually walk around. The temperature at the Martian equator is not much different than high latitude temperatures here on the Earth, okay? 20, 30 degrees in the Martian summer along the equator. So in terms of temperature, it's not a threat. Problem is there's no atmosphere that we can breathe. So we have to terraform, create an atmosphere that's breathable. Okay, there's no plant life, there's no water. A lot of the things we have here on the Earth are missing from Mars. So the idea is to terraform Mars and produce that environment. When we go there, this is what we do as humans. We adapt and evolve. Adapt and evolve. Okay, nature gives us, provides a challenge or an obstacle to us. We adapt and we fix it. Okay, this is what we do. We solve problems. Okay, so terraforming Mars has some very specific physical and chemical problems. Yes, we can plant trees and plants, very hardy, very durable plant life, probably could survive on Mars. But without rainfall or water, even the desert-like environment of Mars, they'd eventually die. So we'd have to provide some form of initial irrigation for them, right? Produce water. Suppose we got that going. So the plants will take in the CO2, that's mostly what the Martian atmosphere is, and exhale oxygen. And thus, eventually, over time, perhaps centuries, or minimum decades, perhaps over a century, more than 1 century, terraform the planet into a suitable environment for the Earth. The problem is, Mars does not have an ozone layer. The ozone layer shields the Earth's surface from solar ultraviolet. Okay, there's two forms, the solar UVA and solar UVB. The solar UVA is a relatively long wave UV, just below the short visible wavelengths, like just below blue and violet. Okay, that's your UVA. Below UVA, we have UVB. UVB is very harmful to the maintenance of life and evolution and the sustainable environment we have on the surface of the Earth in terms of our biosphere. Okay, UVB causes damage at the molecular level to the fundamental building blocks of life, the DNA molecule, the deoxyribonucleic acid, otherwise known as DNA. Okay, so Mars, even if we were successful in producing oxygen, there'd be no shield from the solar UVB, okay? And the oxygen may eventually just escape into space. Okay, so it would be kind of a losing battle. We'd always be looking at maintaining that the amount of oxygen in the atmosphere would be an ongoing battle. So terraforming Mars is not really viable at this point in our technological evolution. Okay, we could exist, we could produce colonies in a controlled environment, glass domes perhaps, that's an environment, or subterranean caverns, live underground. We can produce solar energy, as you know, solar energy is still a viable option on Mars, albeit it's further from the sun and the insolation is less. Solar energy is still a viable option on Mars, and it's a possibility. So we could create subterranean caverns and live under the surface of Mars. Okay, Mars is home to the largest volcano in the solar system, Olympus Mons, right here, Mount Olympus. Okay, that's Olympus Mons. Olympus Mons is a giant shield volcano, the largest in the solar system. Okay, so Mars is a fascinating environment. We could go there, like they say, you know, you can come on vacation, but you wouldn't want to live here. Okay, and that's the thinking we have to, you know, keep in mind. There's some serious decisions that have to be made over the coming 2 decades before we get to that, basically the 2035 mark, where there's, you know, the Earth will begin to show signs of its ability to sustain our continued growth and demand for natural resources. The Earth can no longer provide those after 2035. And those are some real questions that have to be discussed. Okay, so back to Elon Musk's original point. It's not technically feasible. We don't have the technology right now to produce a sustainable nuclear fusion reaction on Earth. That is the energy of the future, and at the end of the day, that would be the ideal energy solution for us here on the planet Earth. NASA is quite right in their comment that it's not possible yet, because to sustain a nuclear fusion reaction, you have to contain a ball of plasma whose temperature is measured in the millions of degrees. Okay, and we do that with magnetic bottling, where there's no physical container. You can put something that's 10, 15 million or even hotter. That temperature would melt through anything. So there's no physical container. So we have to use what they call a magnetic bottle. A magnetic bottle requires enormous amounts of energy. So right now, we're at the break-even point with the amount of energy in and the amount of energy out. Okay, so that's a sustainable nuclear fusion reaction here on Earth to produce energy for peaceful means, providing heat and light for our way of life. Okay, so in terms of producing a nuclear fusion bomb, that's still a technical challenge, and at this moment it's not feasible. Where you would take, well, in the sun, let's briefly go through this. We have the sun, we take 4 hydrogen nuclei, which is a proton, combine them together to form 2 protons and 2 neutrons and a lot of energy. Okay, what's happening in the core of the sun right here is illustrated. 2 protons come together. Okay, this is a 3-step process. Okay, you have a proton and a neutron. That's deuterium. Okay, another proton arrives. Okay, produces a gamma ray. That's the energy. Okay, the same thing is happening in parallel. Comes together. We have 2 daughter products. 2 protons are formed. The 2 protons and 2 neutrons is the helium nucleus, and that's the byproduct of nuclear fusion as it's happening inside the sun. Okay, so the proposal is to do this above Mars, but the reverse of this, to produce this reaction in these string of satellites surrounding Mars. It's not really possible at this point. Okay, it happens in the sun because of the sun's enormous temperature and pressure. Okay, 700 million tons of hydrogen is converted into 695 million tons of helium every second of every day. It's been doing that for 4.5 billion years. Okay, this is the energy, and this is what the proposal is. This is Elon Musk's proposal. Now that we produce this in the form of a small controlled explosion above the Martian surface. That technology isn't here yet. Okay, so that's the proposal from Elon Musk. Okay, friends. If you like this video, please do, give us a like, share with your friends, and subscribe if you're not already subscribed to our YouTube channel, which is a separate subscription from our public website, astronomyforchange.org. Okay, friends, don't forget, always keep looking up.